Hey guys, Mr. Thibodeau here. Let's go ahead and jump into lesson 47, the last one for the week. Okay, powers of 10. Now this is actually pretty similar to what we've been doing in the beginning with our decimals and fractions. It's a lot of similar stuff, especially when we talk about expanded notation. We'll be using this as well. Now, powers of 10 is just multiplying things by 10, okay? Now, specifically when we're talking about 10 times 10, 10 times 100, 10 times 200, or sorry, 10 times, like when we're talking about 1,000, that's 10 cubed. If we're talking about 10,000, that's 10 to the power of 4, okay? And it's pretty easy, right? 10 to the power of 2, there's 2 zeros, 1, 2 zeros. 10 to the power of 3, 1 and 3 zeros, okay? Don't make the mistake of thinking 10 to the power of 2, so I add 2 zeros, right? Because that wouldn't give you 100, that would give you 1,000. So you're not adding 2 zeros, there's 2 zeros in it total, okay? Now, the reason why we do these things is because when we're looking at really large numbers, we can add up using the commas to say that, okay, that's a million. But I also know that a million is an 8-digit, a 7-digit income, okay? So there's 7 total digits there. So that means that there's 6 zeros, and that gives me a million, okay? So 10 to the power of 6 is going to be a million, okay? And that's helpful. When we're talking about really big numbers, it's nice to not have to actually count. I don't have to do any of that. I can just really quickly say 10 to the power of 6. Okay, that's a million, okay? Now, in financial stuff, we're rarely doing these things, though they are sometimes helpful. What we're doing with this is usually it is more helpful to do things like this, where we're doing 10 to the power of 6 divided by 10 to the power of 3, because it is really helpful in, say, when we're dealing with huge, massive numbers, specifically space. Okay, we'll use a lot of this when we're talking about calculus in space. It's just you don't want to have to write how many miles, because it's trillions of miles, okay? Also, this is the beginning of our first instance of dividing by an exponent. And the really easy thing to know is 10 to the power of 6 divided by 10 to the power of 3. That's essentially 6 minus 3, okay? And that gives us another 3. When you're doing exponents and you're dividing them, you're just subtracting, okay? So 10 to the power of 7 minus 10 to the power of 2 is going to be 7 minus 2, 10 to the power of 5, okay? And the reason, divide. The reason for that is because, remember, this is really 10 times 10 times 10 times 10 times 10 times 10 times 10 divided by 10 times 10, okay? Now, when I do this, I can go ahead and I can cross one off here and one off here and one off here and one off here, okay? They cancel each other out, and now I'm left with 5 tens, which equals 10 to the power of 5, okay? And then that turns into 1 with 5 zeros, 1, 2, 3, 4, 5. Put my comma in there, and that's my answer, okay? Now, I don't have to do all of these steps. I could just do 7 minus 2. Okay? When you're dividing exponents is like subtracting the exponents. That's going to change a little bit once we start dealing. If you're doing like 10 to the power of 7 divided by 8 to the power of 3, okay? That's a whole different deal, okay? This does not apply when we're talking about different numbers, okay? That's the math doesn't work out the same way, okay? Because these are two radically different numbers. You can't just say 7 minus 3, because what number is what's your basic number, okay? It's all different, so don't even try. So it only works when it's the same number, okay? Like terms. So I'm going to write that. Only works with like terms. Now, if I, instead of 10 to the power of 7 divided by 10 times 2, what if I did times 10 to the power of 2? Well, that's just 7 tens plus 2 more, which gives me 10 to the power of 9. So multiplication of exponents is basically addition. Only with like terms. Okay? That's very, very important. Only with like terms. Don't try this unless both of these numbers that are under the exponents are the same. Okay? For the rest of this, I think you guys are going to do just fine. I don't think there's anything too complicated here. So I'm going to go ahead and shut up and let you guys get to work. For your written practice, I want you to go ahead and do 16 through 30. Okay? And I think that'll be good for you guys. Okay? Written practice 16 through 30 all. All right, guys. Have a good weekend.